Hey folks, and welcome back to our next geometry lesson. You might be wondering why these are here. Well, we're going to be talking about density today, and this is actually a really great way of showing density. This one is full. To show that it's full and unopened, here's the foil cap. This one is empty. See, completely empty. You can turn it upside down, nothing falls out. Now clearly, they're the same volume because they're the exact same thing. This one, though, is a lot lighter. This one is a lot heavier. I am not going to toss milk around like that. And the reason why is because even though they're both filled, this one is filled with milk, and this one is just filled with air. They have the same volume, but this one weighs a lot more. This one weighs a lot less. And that brings us to our topic of density. The milk in this container is a lot more dense than the air in this container. Its atoms are a lot closer together here than they are here, which we're going to discuss with DMV. Density is equal to mass over volume. Let's take a look. So our aim today is how do we find density when given mass and volume, and we're going to actually work with density, mass, and volume interchangeably, kinda. Now, this is the formula for it. Density is equal to mass over volume. You might have seen it in some of your science classes or previous math classes. Mass is always given in pounds or kilograms or grams or ounces, anything like that. Volume, for our purposes, is going to be feet cubed, meters cubed, centimeters cubed, miles cubed, anything like that. Which gives us density in terms of, for instance, pounds per cubic foot. This is a bit of a weird looking unit, but we would be told density in terms of how many pounds fit in a cubic foot. Normally it's a decimal. Density is never going to really be something easy to get a whole number with. So that was a bit about the units for density. Let's take a look about how we would do this with an example. Now, normally for density, you're given the ideas on how to find the volume, but not given the volume from the get-go. So our steps here are going to be find the volume, plug into the density formula, and then just use a calculator. Let's take a look. So here's our first example. You might want to pause the video and write it in. Now, we're still going to use the formula that we had before. Density is equal to mass over volume. And it's important to just recognize the ideas that we already have here. We have the density, pounds per cubic foot. It's in those units that we talked about. We have the ideas on how to find the volume. We don't have the volume itself, but we're going to use those to find it. And then the mass is what we're being asked to find. What is the weight of the contents? Also, don't forget to the nearest pound, so we need to round. Cool. Well, the volume, this is a right rectangular prism. So we know prisms are the area of the base times the height. And the base is just one of these sides. Let's say the base is 6 times 7.5, and then the height is 5.5. Well, plug into a calculator. That's what we get. For our purposes, we're just going to leave it in terms of the decimal. This decimal is easy to work with. Now, we can plug this stuff in for the density. We know density is 0.29. We know it's equal to the mass over 247.5. Well, now to just solve for this, we multiply both sides by 247.5. And we're going to wind up with mass is equal to 71.775. Now remember, it said to the nearest pound. Well, 71.7 excuse me, is a lot closer to 72 than it is to 71. So our answer here is going to be 72, and it's in pounds. So 72 pounds equals the mass. Cool. So I hope you found that A bit straightforward, maybe a bit new, but hey, this is the first time you're seeing it. Our next example is also what might pop up on Delta Math, and it has to do with a hemisphere. Now, you can find the volume of a sphere using 4/3 pi r cubed. That's going to be on the notes on the next page too, in case you didn't catch it that quick. A hemisphere, just like you know in global, like the northern hemisphere or the southern hemisphere, is just half a sphere. So, if you have the volume of a sphere, you just cut it in half, and now you have the volume of a hemisphere. Let's walk through an example using a hemisphere. Okay, so here's our second example. You might want to pause the video and write this one in. Now, if you're thinking water can't possibly weigh that much, it does. Water is extremely dense. If you had 4 cubic feet of water, it weighs more than me, and I am not exactly a thin human being. So, I have the volume formula right here. 4/3 pi r cubed. This is cubed because spheres only have one measurement, the radius, so it needs to be cubed to get us cubic feet or cubic inches or cubic miles. Now, a hemisphere is just half a sphere, so we'll find this, and we'll just cut it in half. Notice, for the volume, they give us the diameter. So that means that here, the radius is 2. It's not 4. Careful for that. So, let's plug it in and see what we get. Okay, so 16.7552 cubic feet. Now, you might be thinking, but wait a second, Mr. Gallagher, it says round to the nearest pound up here, so why don't we just say this is 17 feet? We're only rounding at the end. We're not going to round at any previous point. Well, we know the density of water, 62.4 pounds per cubic foot. We're just going to plug this in and see. Awesome. So multiply both sides by the volume, the 16.7552, and you're going to wind up with a mass of, if we round it, 1,046 pounds. That is a huge amount of water. That's simply a lot. Okay, so I hope that second example made some sense. If it didn't, check the Delta Math help videos. They're there to help you out. Now, your classwork is on Delta Math. You're just going to go, give them a shot, answer them, do the same thing. Your homework is you're going to explain density in your own words and find one thing that is denser than another, and just explain why they're denser. That's all. So, have a great day, folks. I'll talk at you soon. And if you have any questions, see me in office hours 10 to 11 and 2 to 3 every single weekday. Stay safe.